Hi, Tim Skell here, ABB Sales Application Engineering Manager, and today I'm going to be showing you the harmonic demonstration, including the ultra-low harmonic drive. So what we have here are 3 different technologies of drives, along with some additional harmonic mitigation technologies in this demonstration. What I'm going to do is start over on the far end and work our way towards me with a 6-pulse drive with no impedance, a 6-pulse drive with impedance built into it, and work our way all the way to an ultra-low harmonic drive. So what I'm going to do is start with that 6-pulse drive with no impedance. And what you see here as you're looking at the image is a larger waveform. I'm looking at an individual phase right now. And I see flat topping on the top of the waveform and at the bottom of the voltage waveform. So that's considered voltage distortion. And then the second waveform, they almost look like bunny ears, is your current distortion. So when you see 2 large bunny ears like that, that's a significant amount of current distortion. Current should look just like the voltage, ideally in a perfect world, and they would model each other and be very sinusoidal. When you want to look at current distortion and actually measure it, you look at percentages. So I'm going to come over to this meter right here, and you can see that the current distortion is almost 80%. So this is a considerable amount of current distortion. And I can look at voltage distortion is nearly 5%. So again, a considerable amount of voltage distortion. That drive has no harmonic mitigation at all. What I'm going to do next is move over to a drive with 5% impedance harmonic mitigation into it. So this is kind of your standard drive that a lot of applications will use. And going back to the scope images again, you can see your voltage waveform is much cleaner. There's no more of that significant flat topping, just a small amount of voltage distortion. And then when you look over at the current distortion, you got your 2 bunny ears there, but it's much more sinusoidal. They're not nearly as tall, and it follows that sinusoidal path much cleaner. Now I come over here and I look at my measurement, and I'm under 40% current distortion. So just by adding that 5% impedance in the drive, I went from 80% or almost 80% down to less than 40%. So I cut the current distortion in half, and my voltage distortion went from almost 5 to less than 3% voltage distortion, so much better. Some folks will ask, well, why not just continue adding more and more impedance in the drive? You added 5% into it, you cut it from 80 to less than 40. There's a certain point where you just don't have the advantage of getting reduced harmonics by adding more and more impedance. So I'm adding another 5% as a demonstration. And you can still see I have the bunny ears going on, and I'm only down to roughly 34% current distortion. So I lost a couple extra percent by adding that reactor in there, but really there wasn't a whole lot of value there. Another way to reduce harmonics by not changing the drive technology itself is to add a harmonic filter in front of it. So this is a LCL, an inductor capacitor inductor harmonic filter, tuned specifically to go after certain harmonics. Now you can see that the voltage waveform is even better. The current waveform is much more sinusoidal. And I come over to here and I look at my harmonics, and it's roughly 7%. These type of filters will get you into that 5 to 7% current distortion when you're at full load. So when I started with that first drive with no harmonic mitigation, it was at 80%. Added the 5% internal impedance, that brought me down to less than 40. If I put a passive filter in front of it, that can get me down to 7%. But there's still solutions out there that are even better than that. Also with the passive filters, you have to be a little bit careful on things like leading power factor, making sure your generator is going to operate fine. If you've got questions on that, reach out to an ABB expert. They're more than happy to help answer those questions for you. So what I'm going to do now is come over and show the last drive here. And that is going to be the ultra-low harmonic drive. This is an active front-end drive. So instead of using the diodes, it has IGBTs on the front end. And now, again, looking at the scope image, that voltage waveform, again, no flat topping at all on it. You look at the current waveform, and it's very, very sinusoidal. So now let's take a look at the measurement of that. And your current distortion is 3% or lower. So this is considerably better even than the passive filter. And if I come over and look at voltage distortion, I'm at 1.4%, which at this point is just background distortion from this facility's power supply or power source. So if you're looking for the ultimate in harmonic mitigation, the ultra-low harmonic drive is that solution for you. It's an active front-end drive. It's very immune to things like voltage imbalances. It's able to boost up the voltage if you have a low line situation. There's a lot of other advantages to it other than just harmonics. So overall, you've got your 6-pulse drives with no impedance. You got your 6-pulse drives with internal impedance. You have different external solutions like extra reactors and passive filters. But the ultra-low harmonic drive is that drive. If you've got any harmonic concerns at all, install that drive and you're going to be good to go. So if you have any other questions, feel free to reach out to a local ABB representative or the ABB factory and be more than happy to answer any questions you have on harmonics. Thank you.